All right, hello everyone. Welcome to the second part of the video for section 4.4. We're now going to look at how we can use those logarithm properties that we learned in the last video to do some solving of equations. So let's take a look at these problems here. So we're going to start with the first one. We have log base 2 of x plus 5 minus log base 2 of x equals 2. And so first thing we notice, well, first actually even before what I was going to say, so we see there's some variables in here and an equation or an equal sign. So that tells us we're going to be solving for something here. And because things are being subtracted, all right, well then we can use that difference rule for logs, which tells us we can rewrite the left-hand side of the equation there as log base 2 of, and then remember it'll be the thing inside the first log divided by the thing inside the second log. So we'll have x plus 5 over x, and now this equals 2. And now we have to somehow get the x's outside of the inside of the log, right? And notice in this case we don't have anything being raised to a power. The logs or the variables are not the power of something, so we can't just move them out front. So what are we going to do instead? Well, recall from the beginning of our sections on logs, so we had this equivalence that was something along the lines of log base b of c equals a was the same as b to the a equals c. So we had that was our rewriting something in a log form and an exponential form, and we also did the vice versa of that. So we're going to use a similar approach here. So since our base of our log is 2, we can take that and raise it to the power of the thing on the other side and set that equal to what's inside the log. So what this will become then is 2 squared equals, and then we have the x plus 5 over x. Okay? And now this equation is in a form that we can solve, this 2 squared over x plus 5 over x. So let's go ahead and do that and clear this out. So first of all, the 2 squared, we know that's equal to 4. So this will become 4 equals x plus 5 over x. And then we'll use our techniques for solving rational equations. So we'll multiply by x on both sides to get the x out of the denominator. So this will become 4x equals x plus 5. You can subtract x on both sides. So we end up with 5 equals 3x, and then divide by 3 on both sides, and we'll end up with x equals 5/3. Okay, so that would be our value for x there. Now, notice that the instructions here also told us to check for extraneous solutions. So let's talk about how we do that. Okay, so an extraneous solution is a solution that we get if we do everything correctly, which we did on this problem. However, when we plug it back into our equation, it doesn't make the statement true. So let's look at how we could check that with here. So we have log base 2 of x plus 5 minus log base 2 of x, and that's supposed to equal 2 when x is 5/3. Well, let's check whether that actually works or not. So what we can do is go to our calculator. I can, if you have a newer version of the TI or one of the 89s or Inspires, one way to do this is I hit math, and then if I go down the letter A here, it says log base. Press enter there, it'll actually let me put in the base for the log. So I'm going to make it log base 2. And then we had x plus 5, so we'll do 5/3 plus 5. Then we had minus, and we'll do log base 2 again. Again, the value for x, which was 5/3. Plug that in, we do get 2. So we see that our work there is correct, and 5/3 is not an extraneous solution. All right, let's do the next one then. So here we have log of x plus log of x plus 3 equals 1. So now we have two logs being added. And so we again use our properties of logs, which said we can rewrite that as log of the first thing, x, times the second thing, which is x plus 3, equals 1. Inside the log there, we can distribute the x on the outside of the parentheses. So this will become x squared plus 3x equals 1. And now we use the same trick that we did before, where we're going to rewrite this in exponential form. In order to do that, we have to recall that the base of a log, if it's nothing written there, is a 10. So this would become 10 to the first equals x squared plus 3x. Okay, so that is now our equation. 10 to the first equals x squared plus 3x. So now we'll go ahead and solve that. So if 10 equals x squared plus 3x, we see this is a quadratic equation, so we know we can solve that by setting it equal to 0. So we'll subtract 10 on both sides. So this becomes 0 equals x squared plus 3x minus 10. And we can use either the quadratic formula or factoring to solve this. So if we do that, we're going to find two numbers, or we use factoring, so we'll find two numbers that multiply to negative 10, add to positive 3. So this would become, I think, x plus 5, x minus 2, because 5 times negative 2 is negative 10. 5 plus negative 2 is positive 3. And so from that, we get that our values of x are negative 5 and 2. Okay. Now again, just like on the last one, we want to double check this in our calculators. So we're going to go ahead and plug in the values of x here. So let's start with negative 5. So we want to do log of negative 5 plus log of negative 5 plus 3. And notice when we do that, we get an error. Okay, and I think the error, again, is that we put a negative number inside a log. We're not allowed to do that. Okay, so that tells us that negative 5 is a extraneous solution. Okay, so even though we did the whole process right, negative 5 cannot be a value for x. All right, let's try the other one then, which was 2. So we'll do log of 2 plus log of 2 plus 3. When we do that, we get 1 as our answer. So we see that that one does work there. Okay. So going back to our PowerPoint then, we know that for this second problem here, the answer is only x equals 2. So x equals negative 5 is not a solution. All right, so let's look at the next one. Or one more. So here, we're asked to solve this equation. We have 3 times 2 to the x equals 2 times 4 to the x. And at first, it's not really clear what to do because stuff's being multiplied on the left and the right. We can't multiply the 3 and the 2 to the x because of the exponents, and same thing here. So, what could we do instead? Well, let's try to move everything that has an x to one side of the equation and everything that doesn't to the other side. So for example, if we divide by 2 over here on the right, because that's being multiplied by the 4 to the x, do the same thing on the left. So this will now become 3 times 2 to the x over 2 equals just 4 to the x. And then we can divide by 2 to the x on the left-hand side and do it on the right-hand side, which when we do